Okay, fine. So this is going to be the next question. So it says that 1,000 deposited into fund X, right? Which earns an annual effective rate of 6%. At the end of each year, interest earned plus an additional 100 is withdrawn from the fund. At the end of the 10th year, the fund is depleted. The annual withdrawals of interest and principal are deposited for Y, which earns an annual effective rate of 9%. Okay, so there are two different types of funds, right? So it says that at the end of each year, interest earned plus an additional 100 is withdrawn from the fund. Okay, well, on top of the initial 1,000, we multiply this by the effective interest rate of 6%, which is 60. So from here, this would grow to 1060, right? But the thing is that interest on top of an additional 100 is withdrawn from the fund, right? So, but by the time we reach year one, we're gonna have to withdraw 160 in total, which would mean that we would have 900 left in the fund, whereas at time one in this account, the deposit of 100 and an interest of 60 is made here. The next part of it is that once we get to year two, we would do 900 of what is left times 0.06 effective interest rate of 54. Then this would increase to 954. But since we have to withdraw the amount of interest of 54 plus an additional 100, we would have to do 954 minus 154, and we would get 800 left. That would mean that in Y, over here, we would deposit 100 over here and an interest amount of 54. We go on to the third, we see that 800 times the effective rate of 6% is 48. So this would increase to 848. The thing is that we would have to take out 48 plus an additional 100 at time 3 in Fund Y. And so on and so forth. Now, this is going to go on for 10 years because that is when the fund is depleted. So this would mean that we can calculate the accumulated value of Fund Y at the end of year 10. Okay, so that means that we need to use the future value formula. We know that the one thing that is constant within these increments is the deposits of 100, right? So we could do 100 accumulated value at 9% and 10 years, right? Now, for here, we see that there is some decreasing, right? We notice that if we were to do 60 minus 54, we would notice that it would minus 6. And we see that it is also subtracted by 6 as well here. Well, for starters, we could use the PQ TVM formula. We could set the P as in 60, Q as in equals to negative 6. But we could also use the decreasing accumulated value of decreasing formula. So we could by how much it has decreased, we could set it as 6 times the accumulated value of decreasing of 10 to 9%. Now we know that this part is easier to solve. So if I were to take my TDN calculator, I can set 100 as the payment, 9 as the percentage, 10 as the number of years, 0 as the present value, compute future value, so it's 1519.29. And for the decreasing formula, we know that we start off with 6 on the outside, and then we start off as the number of years of 10 times 1.09 to the 10 minus s to the 10 at effective 9%, all over 9%. Because as we see here, this happens to be the accumulated value of level decreasing annuity. Honestly, I feel like on the real test, I would use the PQTBM method instead, but yes. So let's solve this. So we know that 1.09 to the 10 is 2.36736. Let's multiply it by 10, which is 23.67. Let's solve that small little future value equation. We said -1 as the payment, 10 as the number of years, 9 as this, 0 as present value, compute future value, which is 15.19. So we'll subtract that by 15.19. Then we'll divide all of that by 0.09. Then we multiply it by 6. And then we get 565.575. Then we add it back to the original 1009.29. And then we get 2084.86 as the final answer. And there you have it.